Alright, welcome back again. This is our atomic structure lecture. I did this one in class, but again, I told you we had some issues, so I'm going to put it out there again online so you guys can look at it for the test. We copied this chart down in class today where we talked about the subatomic particles. Definitely know that word, subatomic particles. We have protons, neutrons, and electrons. Okay. The protons are found in the nucleus. They're positive. They have one AMU, which means they got one, basically one. I don't want to say 1 gram, but it's a weight measurement. Okay, we didn't really talk about that in class. We'll go back to that later on in the year. But right now, the protons determine the identity of the element. So the number of protons is the atomic number. Okay. Neutrons, they're also in the nucleus. There's no charge, and they also have one AMU. So when we add these together in our APEMAN, we have 1 plus 1 equals 2. Okay. If we have 1 and 0, then we have, of course, 1. This determines, with the protons, the mass number of the atom. Okay, it's a mass number. Then we have electrons. They're somewhere in the electron cloud, and they have a negative charge. They have a negligible mass. So they're negligible mass. So we don't count them in our mass of our element here. They determine how other atoms react with other atoms. They're in energy levels. Okay, and we're going to talk more about that later on in another unit. So if you need to, pause this slide and go and copy this chart down. Okay, you're going to copy down anything that's in pink from here on out, or red, depending on what it looks like in your computer. Okay, an AMU is an atomic mass unit. It is the size of a proton. It takes that many protons to make 1 gram. We talked about that in class a little bit, but here's what we need to copy down right here. There's the pink. Atoms are electrically neutral. They don't have a charge. There's not a positive, there's not a negative. And that's because there's the same number of protons as electrons. A equals P equals E. APEMAN. Okay, part of APEMAN. So we have the atomic number equals the protons equals the electrons. Chemical symbol. Not going to spend too much time on this. It's the symbol that's on the periodic table. It just tells us what element it is. Atomic number. Again, atomic number is the number of protons. A equals P equals E. Okay? If you change the number of protons, you change the element. So for instance, if hydrogen the atomic number is 1, if I add a proton, then I end up with 2 protons, and I am now helium. Okay? So same thing, if I take 1 away, I'm now hydrogen. It changes who I am. Okay. Mass number. This is the part of the man. M minus A equals N. The mass number is equal to the protons plus the neutrons. Okay? Or you get neutrons equals the mass number minus the atomic number. This one, we change it to M equals, scratch that, M minus A equals N. Up here, you would have M equals A plus N. Because remember, the protons equal the protons equal the electrons equals the atomic number. A equals P equals E. So that's why we can interchange the protons with the atomic number. Okay, we talked about atomic mass. Atomic mass is the average mass of all known isotopes. This is going to be found on your periodic table. It usually has a decimal. So like carbon is 12.011 AMU. Average atomic mass unit. This is for carbon. Okay, this is for carbon. And it is all the isotopes combined. and make sure you have this down, but we're going to talk more about the isotopes. They're elements that have different mass numbers, so we'll talk about that later on. Okay, this is the part that you definitely need to have. This symbol right here is called a nuclear symbol. Okay, this right here, chemical symbol. Without the 2 or the 1, it's just the chemical symbol. So just hydrogen is the chemical symbol. The mass number is how many protons plus neutrons that we have. Okay. The atomic number is on the periodic table. It is the number of protons. Okay. So for instance, hydrogen isotopes, which we kind of just mentioned what isotopes are. All of these are hydrogen, and if you notice, all of these have an atomic number of 1, because remember, it tells us the identity of the hydrogen. This one has 1 as a mass number. So if I do man, M minus A equals N, I take the mass number, which is 1, minus the protons, which is 1, equals 0. This one here, I take the M minus A equals N, and I get 2 minus 1 equals, I'm sorry, take it back, 1. And here, M minus A equals N. So we get 3 minus 1 equals 2. So the number of neutrons is 0, 1, and then of course here's the 2. Early in class I told you protium, this is what we drink. This can kill you, this can blow you up. Protium, drink, deuterium, kill you, tritium, blow you up. Okay, again, being an element tile for the periodic table, the number that is a whole number is the atomic number. Number of protons, number of electrons. This is your ape. Oops. Okay. This is your symbol. This is the name of the element. And then this right here is your AMU, average atomic mass unit. Okay? Your average atomic mass. Okay? And what we're going to do for most of it is just round it, so it'd be at 23. Okay? So if we were to, that would be our mass number. There's a difference between a mass number and an average atomic mass. The mass number is a whole number, and the average atomic mass is a decimal. Or, like in plutonium, let me put it up here, Pu. Plutonium has parentheses, and I cannot remember the number of, I think it's 2 something. Not sure about that one, but it has parentheses around it. This means it's man-made. This with the decimal means it's naturally occurring in nature. Okay, so APEMAN, a way to remember all parts of the atom. You have A equals atomic number, so A, protons equals electrons, ape. Okay, all of these are equal. Then you have the man, M minus A equals N. There's your subtraction. Your atomic number minus your mass number gives you your N. So if you always start with, and let's do helium, 4/2 helium. If this was your nuclear symbol, 4/2, then all you have to do is subtract these and you get your neutrons. Okay, let's see what else we got in here. So for instance, if I take sodium, sodium has, if you remember from the chart, sodium is Na. It is 23/11. And we're going to learn about what this symbol, why this symbol's here, because this is another symbol, but we'll worry about that later. But 23 minus 11 gives you 12 neutrons. just like what we have here. Okay, I believe that's it. If you want to fill in this chart, fill that in. You can bring it to class and I'll check it for you. This is just more practice. Okay, guys? Have a good night. Let me see if I can stop this.